Okay, now let's look at subsets of the set of real numbers. As a reminder, real numbers are defined as any number that can represent the distance of a line. So that's pretty much any number. Fractions, pi, those are all real numbers. They could all very well define the distance of a line. And we write that as this symbol here. It's like an R with an extra side to it. That's how you would denote real numbers. So a set of real numbers would be an infinite set. It contains numbers that go on forever and ever and ever. So that set would be infinite. And any infinite set also has an infinite number of subsets. It could have the subset 1, 2, 3, or the subset 5, 6, 7, and that goes on and on and on. So an infinite set has an infinite number of subsets. But if we're looking at the set of real numbers, we usually only look at about 5 subsets that matter to us. So the first set that we care about is natural numbers, which we write as n. And that would just be numbers like 1, 2, 3, 4, 5. These are also often called counting numbers. The second one that we care about are whole numbers, denoted by the letter W. That is all the counting numbers, the natural numbers, plus 0. The third one that we care about are integers. Those are denoted by this fancy looking Z. Integers are whole numbers plus all the negative numbers now. So we have all the natural numbers, all the whole numbers, and now we have negative numbers as well. So I can say that's all the whole numbers and their opposites. The other thing I care about are rational numbers. Rational numbers is any number that could be represented as a quotient or a fraction of integers. So each of the following numbers are all rational numbers. 1/4 is obviously a fraction. Negative 3/17 is a fraction. Negative 10 could also be written as negative 10 over 1, which is a fraction. And then a decimal is also a fraction. So rational numbers can also just be called fractions. And the last thing we care about, irrational numbers, are any kind of number that can't be expressed as a ratio of 2 integers. It would be very difficult to write down this number. Something like pi is infinite. The amount of decimal places goes on forever and ever and ever. It's irrational. It can never actually be rationalized. You can never fully write out pi. Something like the square root of 2 cannot be rationalized. It would be an infinite decimal as well. You have to always write it as the square root of 2 to be the most accurate. There's a very useful chart on page 249 of your textbook that will help you break down real numbers and understand what all of these sets are subsets of. So let's look at these example problems. We need to identify what subsets each of these numbers belong to in all the subsets of real numbers. So I'm going to look at the chart to help me. 1/2 could be a subset of a lot of different things. First off, always write that it's a subset of real numbers because any number is a real number. So it belongs to that subset. 1/2 also belongs to the subset of rational numbers. Because remember, rational numbers includes all of the fractions. So those are all the sets that it belongs to. Number 2, what is 5 a subset of? 5 is a subset of everything. If we look back up here, 5 is a natural number, it's a whole number, it's an integer, it could be shown as a fraction, but it would not be irrational. It belongs to the naturals, the wholes, the integers, the rationals, and of course, the real numbers, because everything is a real number. Lastly, 3√2. What subset of real numbers would that belong to? Right off the bat, real numbers, because everything belongs to real numbers. And it would also be an irrational, because we can't really show that as a number. Let's try some other problems that go along with this. Okay, we need to determine if these statements are correct. For number 1, are real numbers a subset of integers? Well, real numbers are the heading of everything. Everything is a subset of real numbers. But real numbers can't be a subset of anything else because real numbers include things like irrational numbers, but integers do not have irrational numbers. So this statement would be false. Are irrational numbers a subset of real numbers? Yes, everything is a subset of real numbers, so that would be true. Are irrational numbers a subset of rational numbers? Irrational numbers are on their own. They don't go into anything else except for real numbers. A rational number includes things like fractions and decimals. An irrational number doesn't look like that. It's irrational. So that one would be false. Are whole numbers a subset of natural numbers? Well, whole numbers, the only difference is that they include 0. Natural numbers or counting numbers do not have 0. So that means that whole numbers cannot be a subset of natural numbers because it has 0 while natural numbers do not. Are integers a subset of real numbers? This is an easy one. Everything is a subset of real numbers. True.